Hello, hello, how we doing today? Welcome to week 2.5, basically, at this point. So, how did the rest of arrays and the introduction to objects go?
Painful.
Why painful? Why?
There are a lot to grasp, and especially the problems that become more and more and more nested. You just need to figure out how to access all those objects within objects within objects.
Okay, is there one problem from last Thursday we want to go over real quick then?
Well, the zoo gave a bunch of people a lot of grief, but I figured that one out. I think the only one I haven't finished at this point is the last one, the attendance count.
Okay, so show of hands, do we want to go over a problem? Yeah, okay, do we want to do zookeeper or attendance? Zookeeper? Alright. How was arrays 2 though? Is most of our problems with objects right now? Cool. Alright, let me just boot that up 1 second. Which one is zoo? Pet sounds? Is that it? No. Dog breeder? Looking at the names of them. It was on arrays 2, zookeeper?
Oh, sorry. Then it's not the zoo. I'm so sorry.
That's okay. I know zookeeper's annoying also.
Yeah, the zookeeper was super annoying.
So pet sounds, do we want to do that one? Alright, let's do pet sounds. Alright, so is this the one that was giving some problems?
Yeah.
Cool. Alright, so write a function pet sounds that's going to take in a string that represents an animal name and a country name. Then, using the globally defined animal noises array, pet sound should return a sentence that explains which sound the animal makes in the given country. Okay, so it looks like they're going to give us an animal name. And for whatever reason, we have this array of objects. Is everyone still with me here? It's really important that when we first start any sort of problem, we kind of have to look at the data that we're being given and sort of, figure out how we're going to access individual pieces of that data and plan out sort of the architecture and the patterns that we're going to have to use to get to the levels that we want to get to. So it's good to know that we have an array and then we have objects at each element. And actually this is purposely being annoying here because there is no reason that we couldn't just have one top level object where the top level properties are dog, cat, and chicken. Because each of these arrays represents one object that only has one property in it. Does everybody see that?
Yeah.
Do we kind of see why this would actually be a little bit easier if it was just one object right off the bat that gave us an animal name? Because if we had dog and cat all at the top level of one object, we can immediately plug in the animal as the key on that overall object. And what would our value be? So that's a really open-ended question, but pretend we had this hash, this top-level object hash, where we had dog, cat, and chicken. As soon as we plug dog in, we would immediately get back this data structure here, which if we're looking for a country, what could we do there?
That would be key.
Yeah, again, we just plug in basically on our animal hash, we'd plug in animal and we plug in country and we'd immediately get the sound that we need. And that's how it should be in real life, and that's one of the benefits of objects, is once we know what we're looking for, we can plug it in directly and get out the result we're looking for without this algorithm where we're going to have to loop through a set of data and come up with a way to find the actual data that we need. But besides the point, that's not how this problem actually is. So instead, if we're just looking at this and we know that we care about chickens, what are we going to have to do? And I'm going to zoom out a little just to make this easier to see. Or actually, let's just condense this so we can see the whole data structure. Any ideas on how I can find the object that has chicken inside of it?
Square brackets.
So what is this called? Pet sounds in English. So without going into actual code yet, what is sort of the pseudocode for this? We're giving a list. We don't know where anything is inside of that list, right? What does that mean we're going to have to do? Index of could do it. Includes, does that really help us here? Because includes will let us know if it's in there or not, but that doesn't tell us how to get there, right? So in general, if we have a list of items that are placed in no specific order, what is the common process that we have to do to find the item we care about? What's that? Yeah, so I think the word that I'm looking here and that we probably all have the same idea is that we need to iterate. We need to iterate and so that means, how do we know what we're looking for? We want to find an object that has what? If we're looking for chicken, we want to find an object that has what?
Keyboard chicken.
Okay, so let's leave it at that for right now. What does the code sort of look like for this? If we need to iterate over this list of objects up here, what is that? A regular for loop, yeah. And say it before I type it all. No code pen shortcuts. Okay, and then one thing about CodePen. Does anybody know why animal noises here is showing up in yellow? Yeah, so this is just a little visual indicator in CodePen. You can't count on this in every editor you ever use. But actually, if a variable shows up in yellow inside of anywhere in CodePen, it's telling you, hey, this thing here isn't defined in the local scope. It's actually the one that's all the way out here on the global scope. So out here, it's blue because it's being defined in that scope, but it doesn't exist inside pet sounds, which is why it's gold. And so we can just demo that behavior right here. And it switches to blue because now there is a local definition. Don't let that be a handicap. You should still know why that thing is on the global scope, but it's a quick reference. Okay, so generally when we're iterating, what is the first thing I want to do? We have this annoying I variable, right? Yeah, so we could just say what? Yeah, let's go with the animal object because it's more clear. We don't have to remember later, hey, that thing is an object. But it's really important that we do know what type of data each variable is because that controls how we access it. So animal object is equal to what? And let's just go over to REPL instead, actually, so we can demo things easier. Yes. I know we're not at that point yet. But why is this actually undefined right now? And yeah, that's the point. We build up very slowly. We're just figuring out how can I pluck off one piece of data at a time. We're going to solve one part of the problem at a time. I haven't even really looked at the overall problem that we're trying to solve. We're just figuring out how do we narrow down this list to the one thing I actually care about. And now, I actually have an error in here. What is it?
Like should be less than instead of less than.
Oh, yeah. Thank you. So now we see that we're correctly logging out each individual animal. And so this visual lets us know that every iteration of this for loop, animal object is one of these things. We don't really have to worry about the array anymore. We've kind of solved that array problem already. And now we're just looking, okay, if I have one of these objects in memory, how can I tell if this object includes this property? Okay, so for in, let me just, what is this right now? We're just demoing something else real quickly. So animal noises is the array. We can't see the whole array. But what is animal noises 2? Or the object that holds chicken, right? Like this actual object here would be the value of chicken. So let's go one deeper and access chicken. What is that object now? That's going to be the noises of the chicken, yeah. So for in, what does that do?
Iterates through the object.
So this here, we've just saved object is a reference to this object over here. Still with me? We're all over the place right now, but we're going to plug it in together. So we have this object in memory as obj. And now we're saying for each key in the object, give me an iteration of the for loop where the key will have each of these values. America, Germany, England, etc. And then how do I get a sound? If I have a key of an object, how do I get the value?
You access the key.
Yeah, we plug the key into the object. And so this is kind of the same as when we have an array. Arrays are objects under the hood, and I is the numeric key that we plug in to get the element that's at that spot of the list. But objects aren't based on their position. They're based on an actual value of a key, a string value. So here we get each key in the object the same way we would looping over a for loop, and we plug the key into the object with the same exact bracket syntax. Why is this a bracket instead of...
Because we don't actually know what we're looking for.
Well, what does this look for over here? Yeah, so this is literally looking for a property called, for a string value called key. But really we're telling JavaScript, no, we're not looking for a property that's called key. We want you to look at what the string value is of this key and use that to get us a value. And this is going to continuously change because of the for in loop. This key is always going to update to be each of these values. So once we have one of those properties, we plug it back in and we can get a sound. So that's what the for in does. But that's not actually helping us that much. It's kind of giving us more logic, and there's a lot more noise. Because in the example of our problem, if we only care about England, or I think we're actually using this to figure out if chicken was in a property, if we're trying to find chicken, we don't really need a loop of all of the properties on this top level object. We really just want to know if chicken is inside of that object, right? We don't care about any other key. Now in this example, each of these objects only has one property, but still that for loop is a little unhelpful. That's not actually what we're looking for. Instead, let me just Okay, so we've got this object in memory here, right? What we're actually looking to say is so if we don't use that for keyword, the in operator will give us a true or false to let us know if that key is in the object. So down here, this is the object that we're working with in memory. And I said, hey, is there any key in this object with the string value America? And it says, yeah, true, America is a property on this object. But this string here, ASD whatever, is not in this object. That's really all that we're looking for, right? We don't really care about every single key that's in the object. So that was a quick review of what for key in object does, but the takeaway here is that this in operator is more than enough for us to know if a property exists on that object.
So then we don't need the whole for in loop. We could just use like country in.
Yeah, because that for in loop was now going to make us add another level of if checks over here to say, hey, is our key America or chicken or whatever it was? And it's getting wide, like we're adding a bunch of nested curly braces, and it's adding more logic that makes it harder. So instead, the only thing we cared about is, does the key exist in the object? Because then it's an animal object we care about. And if it's not, then we can continue, right? So down here, how can we determine if the current animal object we've pulled out is the animal or is the object that has some information about the animal that we care about?
Then we could do animal in animal noises.
Yeah, but this time we actually want to use the true or false value, right?
In country in animal object.
Exactly. So now we can just go, wait, we're actually not at country yet.
Okay.
And that's because if we go back to CodePen, these were the objects that we're getting at each iteration of the for loop. And we want to know if our animal is in the object that we've pulled out, right?
If animal in animal object.
And so we're just going to stay slow, actually. Let's go back over here. Put this back on. Okay, so before when we ran this, we had 3 objects being logged out, right? Because we were logging out every single animal object. But now we've added 1 bit of logic, and we're trying to see, hey, can we now just find one top-level object that has 1 property representing our animal? And we now have that, right? So far, the algorithm's working. We're going step by step, figuring out how do we pull out 1 level of data at a time. And so now we know that if we hit this bit of code in here, we do have this top-level object that we want to eventually go deeper. And I want to access this object now. So we know we've got 1 top-level object with 1 property that is actually our animal variable. And I want to access the value of that property. What can I do? How do we get the animal noises?
Now you can do the for loop and save country as the as animal at the key.
So I lost you a little bit, but you said for loop. And I think that you might be 1 step ahead of us if we actually got this object. But we don't have this object selected yet. We have this object, and we know the name of this chicken property. So what can I do to get this? No ifs yet. I just want to select it, right? I've got all of this in memory as animal object. And I have chicken as my animal variable. So don't I just want to plug chicken into this overall object so I could get back just animal noises? Okay.
I was following it, but now I'm not. Can you tell it again?
Yeah. So this data structure is really annoying. I'm not going to lie. Like, this really serves no purpose, and it's adding a lot of confusion.
It is. It really
It
is.
is.
The way that it's built, I'm pretty sure that's just getting me.
It is. So it is. It's not a good way to build an object at all. And we pretty much threw out all the benefits of using an object. We threw out by putting them in this animal noises array with one top level property for no reason. But bear with me again. Let's just look at this thing in isolation.
Oh, okay, so now you need to grab a separate object that is just animal or the animal noises or the chicken noises, whatever.
Yes, but for the visual here, maybe this makes it a little bit easier to see. We have this object here, obj. This is its value. Obj has one property called chicken. Can we see that clearly now that there's only one property on the obj object? And it's got the string value chicken. So if we know the property name of a property, how do we get its value? It doesn't matter that this is an object, it's got 100 countries. Yeah, so we want to go to object chicken, right?
Yeah.
So basically if I had somewhere else as a variable, with these two pieces of data, how can I dynamically grab this? And we've just said it, just say it again. What is the code here?
Chicken bracket value.
Very flustered. Okay, so what is this thing's name? What is its variable name? We want to select this, right?
Chicken.
Okay, the variable, no.
Object.
It's object, right? We've got object's value is this huge object here, right? We just selected it. With code, it's obj. And now we have some other variable called animal name that ties to a property up here. So we want to plug this variable into object to get this value, right?
Yeah.
So what does that look like?
Square bracket.
If you wanted to do it with chicken, it would be oh my god. It would be that, but like our algorithm needs to work no matter what chicken is. So we're just storing a variable that has that string value. No matter what the string value is, we want to plug it in, right? So sometimes it'll be chicken, sometimes it won't. But it's in the case that it's dynamic, it's animal name. And so to get this value, we're saying, hey, let's go on this object and let's plug in that dynamic key. So when we plug in the chicken value, or the string whose value will be chicken, we'll get back this. That's actually what we have so far in the algorithm. And so I think it's a little bit easier for you to see it here when it's just an object sitting right here. But that's actually why we've solved this one step at a time in the algorithm here. We pulled out animal objects so we don't have to worry about the array. And now on animal object, we're just practicing how do we go one level deeper so we only have to think about this from here on. And now we just said if we've got this animal object here and we have an animal name, we could just plug the animal name in and now we can select this. So what we're constantly doing here is we're just getting one deeper level of data at a time to make it easier on our head to solve one step at a time, rather than have some mess that would look like this. And have to keep this up throughout our entire algorithm. So that's why I'm going one step at a time, and that's how we really need to think as well, because that's not easy to look at, and it makes your head hurt. So instead, the same problem we just had, we know that we have some animal object that looks like this, and we know the animal is in the animal object, which means, whoa, it's one of those days of the multiple keyboards. Okay, so we've solved one step at a time, and we're finally at the point where we just have a mapping of countries to a sound. So yes, as Elliot said, this problem does require one additional step, but that step didn't matter at all up until this point. So now we know in memory we've got one object, and it's got a bunch of country values and their sounds, or country property names and their sounds. If I'm given Algeria on this object, how can I get back this value? What did I do, Ron? This is a really good demo. So I'm logging out undefined from line 80. Why is line 80 logging out an undefined value? No, I specifically said, hey, let's go look for the sound with the key country. And that's not what we're looking for. We actually want it to be Algeria, which changes. It's whatever comes in as this country variable. So this should be what? So again, all we did is we reduced it to one step at a time. We just pulled out one data structure. Once we finally had this data structure, we don't need another crazy for loop. We said we know we're looking for the country on this object. So why don't we just plug country into this object directly? And that's all that we're doing down here on lines 80 and 81. So I think that this problem, one, might have been a little bit overwhelming because we do have nested data structures. And two, that array makes absolutely no sense other than to confuse you. So I would encourage you that we did most of this without even reading the prompt. Whenever we start with a problem here, we want to look at the data structure at the high level and figure out how do we go down one level at a time. And our first problem was with this array, we need to figure out which object we actually want. So we started by logging out each individual object. And that was done by plugging the index into the array and then just logging out each of those objects one at a time, right? Which makes it a little bit easier to reason about once we've pulled out just one object. Then when we had one of these objects, the next problem that we had was how do we know if this is the one that we care about? And it seemed like the trick there was that we didn't know the in operator could give us a true or false value. So we just plugged the animal into each of these objects. And we said, hey, if the animal is in this object that only has one property, then it's the one we care about. At which point we're just working with this structure, which is where we just got hung up a few minutes ago. I was like, hey, if we just have this structure, how do we go one level deeper just to this hash of countries and noises? As well, just plug in the property that we just were looking for, that animal. So when we plug dog into this object, we got back the country list. And now, Maria, why did you say that you thought we would have to for loop over these countries?
I don't know, because I've been using way too many for loops recently.
Yeah.
It's like answer everything before loop.
Yep, so that is a problem. We definitely need to have muscle memory on how to do a for loop, but it's more so we have to actively think about the current data structure that we're working with and know the benefits or not benefits of working with it. Sorry, what am I saying? Okay, with objects, if we have an object of a bunch of countries, the great thing about objects is that we could look things up directly by the key that we're looking for. With arrays, we're so used to, hey, we have no idea where this fucking thing could be. We need a for loop. But that's kind of a train of thought that we need to separate between arrays and objects. Objects, we can directly plug in the password to get the value that we want, where in this case, the password is the country. We could just get a sound. Actually, looping through this whole thing isn't doing anything for you, because eventually your loop is going to give you the key as a country, but you kind of already knew that the key is a country. So even when you have that for loop and now you're saying if my key is the country, you're still plugging the country back into this object, which you could have done without the for loop. So that's just something to consider, is that the great thing about objects is we can directly look up whatever we want once we've selected the object that we care about. So for loops are great and we use them a lot, but let's not blindly reach to for loops, because if we already have this thing, we could just go directly at it. And so that's what we have to consider, the difference between objects and arrays. So this one was kind of messy. I hope that we didn't confuse you more. The big takeaway is that this can be used to make sure we're working with the correct object. But once we know we have the correct object, we can just plug keys in. And because most programming should be dynamic, we're usually going to use bracket notation with a dynamic variable that can work no matter what the country is that they give us. Because whatever they give us as this variable when it's in brackets, that string value will be what we actually look for. We're not actually looking for something called country. We're looking for, hey, we want a key whose value is the string stored at the variable country. Does that make sense? Do we feel like we could redo this problem? It might take a little bit more time, but if we start one at a time and log out the data structures, do we think that we have a better grasp on how to solve this one? Okay. And so I think that this one was a good candidate for why I'm really recommending to use REPL, because it was a lot easier for us to look one piece at a time and log out visually what is the state of the data that we currently have access to, and then how do I just select the next thing. And in CodePen, with all of those test specs all run in your function a few times, it's really hard to get a grasp on your console logs. But console logs are really important. We do need visual indicators for what the data is that we're working with. And we can't just blindly guess in CodePen and throw brackets around and throw eyes around, because it will seem impossible that way. You're basically looking for a needle in a haystack. Here we need to go one level at a time and visually look at it so we can make the connections ourselves. And that's why REPL will really help you as beginners to know what your code is doing, to step in and look at it. I'm actually speaking with FullStack right now about getting rid of CodePen and test-driven development precisely because of this problem where I feel like it makes you feel claustrophobic and that you can't poke around under the hood and see what the data is doing. And you really need to be able to. It's the only way. I mean, you can't just memorize looking at that last diagram or the full problem spec. You can't memorize how to get to what you want. You have to see each level of the data until it becomes second nature. So please start using REPL and messing around with the data structures because it will really help you to visually go one step at a time. So is this helpful?
Yeah.
Good we spent time on it? Okay, cool. Any final question?
No, I just wanted to say, like, speaking from experience, my progress has gone through the roof when I stopped using CodePen. And I just console log every single step I made and just seeing where the mistakes are. Because I was having so much problems just trying to match the Jasmine spec list.
Yeah.
And it just drives you absolutely fucking mental.
Yep, okay, so I'm going to quote you directly when I speak with them again. That as soon as we got rid of CodePen, your progress improved, which is a standalone sign that CodePen is not helping us at this level. Test-driven development is great, but I think it's something that we need to apply more when we go to the actual curriculum to test applications, rather than lock you into this bit where you don't know what your code is doing and you don't feel like you can look at it. So I think that that was a mistake that we implemented that. Thank you, Elliot. I can't speak highly enough that we really have to go one line at a time and visually see what the code is doing. REPL is the best way to do that because we control everything. We saw here's a good example too. Like, let's just isolate it, one part of the data structure away from the problem. If we had this data structure here, how did we go get a country? And we solved it like one step at a time. I know it took a little to get there, but once we figured it out, it was easier to plug that into our algorithm then try to solve it while the whole fucking thing is running 4 times in a row inside CodePen, right? Yeah, okay, we're gonna get rid of that. Not for your class, but we'll get rid of it.
Started commenting out some of the.
That's good.
things.
To comment out
So
the
I
test
look at the
specs
one
is
that
good.
I'm failing, so I'm only seeing the one come up because I started console logging really like hardcore this weekend, and it really helped me.
Yeah, console log is your friend. It's never gonna have any adverse side effect. We just have to organize ours. Another tip is to always, console log takes unlimited arguments. Always put a string that says what you expect to get there, because if we just have a bunch of console logs and one is undefined, you don't really know where that undefined came from. Okay. All right, moving on. Sudoku project, how's it going? Okay, so a couple of things. Good. Good. Is it easier than this? Do we actually like Sudoku project?
Oh, I like
Okay.
it. It took some really painful moments to get the grid, but
Yeah.
and some tears and
Some tears, great.
But I got that.
Well, I'm glad to hear that. So one thing, if you haven't attempted Sudoku project yet, it's due Thursday. That doesn't really mean much. You can send it to us after the fact. I don't know if Sarah will, but I'll always grade it and get feedback to you. Grade it, I mean, I'm just going to give you comments. There's no grade. Now, from an algorithm standpoint, the subgrid is the hardest part, and that might take a majority of your time. Don't worry about that immediately. See if you can write an algorithm that's, one, able to get each column, because we want to write functional. We want really small functions that we reuse over and over to make a readable main loop rather than have 20 for loops. I mean, the main function is very small. It says go get all columns. Anyway, write a small function that can get a column and can get a row. And then make your main function get all of the columns, get all of the rows, and then check whether all of those are valid. So at the lowest point, there's one function that expects to take in a set of 9 numbers. Doesn't matter if it's a column or a grid or a row. It should just return whether a set of 9 numbers are valid. Then if you have all the rows and columns, we could just return whether each row and column is valid. So Sarah will cover this tomorrow. She won't cover this specific method, so ask her. Or sorry, she'll cover this on Wednesday, but I just want you to be aware of it. I'm here tomorrow. She'll cover this topic on Wednesday and Thursday, and this function specifically isn't in the slides, but I want you to be aware of it. So we're taking a little bit of an aside here, but this is a topic called higher order functions, which are functions that take a function and they run it for every single value inside of an array. She'll cover the basics of this on Wednesday and Thursday, but this one specifically is really helpful on the Sudoku problem. So we're not going to fully cover it right now, but imagine every or higher order functions in general, the argument that they take is a function. So in this case, we defined a function called is below threshold, and it expects to take in one value. And what every does is it's going to call this function with each value inside of this array, right? And then so it's just returning whether each value is less than 40. And what every is going to do is it's going to tell you whether every single value in this array passed that little helper function. So this is telling us every value in here is below 40. Does that make sense at a high level? We don't have to understand the code, but if you can at least read line 7, does that make sense why every number here is less than 40, right? That's all it's telling us. So that means if we instead have one function here that expects to take in a row, or not even a row, not a column, just an array of 9 numbers, you can implement your logic here, whether those 9 numbers are valid. Still with me? That means if we built up one huge array that we put every row and every column, so now it's a multi-dimensional array where each element is actually not a list of 9 numbers that are either a row or a column, the final line of our main function returns whether all columns, all grids, and all rows dot every is valid set of 9.
So like, let's say if we were doing this for 9, instead of saying 40 up there, it would be less than or equal to 9.
Yeah, but this one is this one is kind of not as parallel because this one is only taking in a single number, whereas really what we're going to have is basically like an array of like 1, 2, 3. So we can imagine like we have a list of 1, 2, 3s. And now we could rewrite our helper function here to return whether each of these current values has all of the numbers 1, 2, 3. Then we just worried the main algorithm is building up a list of all of the sets of 9 numbers we can get out of Sudoku. And the final line is whether every single set is valid. So you'll be able to implement that after Wednesday and Thursday, but the point I'm making is that our whole algorithm now becomes let's get a column, let's get a row, let's get a grid, and let's write one function that returns whether 9 numbers are valid. Then if we can get all columns, get all rows, get all grids, and make one big list, we just return whether the list is all valid. And so we only have 4 real small functions there, and that's the entire algorithm. And of that, get subgrid is a pain in the ass. So I'm saying put that one on hold and see if you can at least attempt this thing just to get all the columns and all the rows. And after Sarah covers how these work on Wednesday and Thursday, write it like this, and you'll see that it's a lot more readable, it's a lot more clean. And then you can always go re-implement subgrid whenever you want, which is just nested for loops, and it's annoying and there's no way around it. But that's not really the hardest part. It's writing these small functions and combining them. And that's what I would want to see. I don't care about the subgrid as much. So whenever you get a chance, do that. You can send it to me. I'll give you feedback. But this every function, it would be really great if you can implement this after Wednesday or Thursday.
If we get stuck, can we send it to you before we finish it and get feedback?
Yes, I know somebody sent it to me today. I wasn't able to respond. So it'll always be like sometimes I get back to you instantly. Other times it might take 24 hours. But I'll always give you feedback when I get to it. So don't hang on me. Keep working. But I'll always update you, of course. Cool? All right, so now arrays versus objects. We kind of ran into this problem today. Just at a high level, somebody tell me, what is an array? An ordered list. That's the really important thing about arrays, is that they're ordered. And so generally, if we don't care about an order, an array is going to give us more problems than using an object instead. Because if we don't care about the order, we probably care by some identifier, right? So we probably won't get time for this example. I'll do it tomorrow. But these aren't actual phone numbers, but pretend that we needed to represent a phone book in code. So this phone book could potentially have billions of phone numbers inside of it. But we all know that only one person can have a phone number, right? Phone numbers are unique. That's a unique way that we can identify a person, even if all of our people have the same exact names. It doesn't matter. So, would we want to store this inside of an array?
No.
Yeah, hypothetically, if we stored this inside of an array, which would still be objects, where we have like number, whatever, and then like name, whatever, and then I had 20 more of these objects. If you told me to go find me somebody's name in this array, in the worst case scenario, I have to loop through a billion phone numbers and say, hey, is this person the number I'm looking for? Is this person? But in a phone book, or when it's represented as an object, as soon as you give me a number, I can immediately just go plug that number into the object and get back the name of the person who's there, right? So in the instance of a phone book, the order doesn't give us any, if we want to represent a phone book, an order doesn't help us at all. But there is some unique identifier, and that's a phone number, and we can use that as a key. And this means that instantaneously, no matter how big the phone book is, I plug in a number, I get back a name. An object works really well to represent that type of relationship, whereas an array means that we have to write a for loop that potentially goes billions of lines and is now giving you nested and complicated code. Because at every step, you're now plucking out an object, and we just saw how hard that was. So that's the main difference between the two of them, is that if we have any identifying characteristics and it's not order-based, object is generally a better way to store that data. Although because we have used arrays more often, beginners will often try to represent every problem with an array. And this is where you really need to analyze the trade-offs of the two, think about the problem that you're trying to solve, and then pick the best data structure to use. So, we spoke about queues and stacks, right? Which are data structures. They're using data types in JavaScript to represent something bigger. Well, when we use an object with unique values only, where each unique value is like the same thing, like they're all phone book here. It's not like I have a student where I had like name, age, and grade. Like this is just an object. But when I use phone book in this way that each key represents something, a unique number, this is called a hash. There's no difference about how we use it at all, but if you ever hear of a data structure called a hash, this is it. And a hash just means we can look up basically instantaneously any value, no matter how big it gets. And that's where the real strength of objects comes in. So yeah, the big takeaway is that arrays are ordered and we access them by what? Numeric indexes. We use brackets for everything. We use brackets how to access characters in a string by order, or how to access elements in an array by order, or how to access values of a property on an object by a key. We use brackets for all three of those. So brackets aren't unique to arrays. It's more so that we do it with a numeric index. And objects, we use a string value that represents a property. So quick review then. This might be a little bit easier now. How can we log out each student's name?
Student bracket.
Okay, but first we have to get to that point, right? Like, in code, what code can I write that can allow me to log out each student's name? So student is, in this student's hash, actually, what are these? They're keys. So how can I get every key of an object? Okay, but because our keys actually have a real life meaning, we're going to call it student name. So let each student name in students. What can I do? Do I have the names? Okay, great. So one step at a time. We had a hash. Again, this is like, we can represent every student in this class in a hash because you all should have a unique name, or we'll find a way to make it unique. And then no matter who the student is, no matter how big the class is, if I say I'm looking for Noelle's grade, it doesn't matter if I have a billion people in the class. I directly go to like my class object, and I plug in Noelle's name, and I get back her object there. So now how can I log out each student's grade? So first, how can I pull out one of these for each student? I have a student name, right? So I need to plug student name back into this overall object. What's that?
Oh, never mind, that's you finding it. Wow. Never mind, I'm saying it.
And so now I see that I have each of these, right? I have each of these objects now as what variable? Yeah, what did I call it? Student object. So if this is what student object is, how can I get a grade? Why? Why do we need a for loop? I've got this thing in memory.
If grade and student.
Yeah.
Oh, we have the grade, yeah.
I don't even need to check if grade. We're assuming that these have gone in through some API. Every student should have a grade. So I'm specifically looking to just grab this number here on this object, and I know I'm looking for something called grade, right? Yeah, in this case, I'm going to hard code .grade because I'm assuming grade should always be there because this is some API where students should have a grade. So that was it. We just went through that whole hash. We pulled out, basically we got each key, made sure we got each key, plugged the key in to get this. And now if I have that object, I just cared about the grade. It doesn't matter if I've got a billion things, we only want the grade. So I can log out students and their grades, just like this. Okay, so that's how we traverse the data structure. We figured out how to get the data that we wanted. The real problem is that I wanted an average of all of my student grades. What is an average?
You add up all the totals together and divide by the number of things you added together.
Yeah, so we need some way to aggregate all grades, sum them all together. Sum all grades, would we prefer that? Okay, sum all grades. So let grade sum. If we have a sum, we need to initialize it at some value that's going to play nice with adding numbers together, right? What's a good number for that? Exactly, so these are the patterns that we have every time we try to solve a problem. First, we figured out how to traverse the data. You didn't even know what the real problem was yet. We figured out how to get grade. No, I just had you figure out how to get grade. Now we're figuring out how to sum, which means we need to make these aggregate variables, and this is always going to be a pattern that's outside of my for loop, right? Because this needs to persist after the for loop. And so we figure out what to initialize it at. If we're adding numbers together, 0 is a really good one to start out at. And what do we think is best to know the amount of people I've added to this sum? Because we said that an average is equal to like the grade sum divided by amount of grades, right? So how do I know the amount of grades?
Let number of students equal 0.
Yeah, we have two choices here. One is that we could make number of students, and every time we add to grade sum, we could increment that, right? But the number of students is also equal to what? So it's not just the length of the students, but it's the length of what of students? Have we seen this?
Or the number of keys.
Yes, it returns the array of all the keys.
Yep, and we're in suspense because REPL's backend is very slow right now to run this one line of code. But this is going to return us back an array with what values? Yeah, so Chris, Noel, and Gabe. And if it's an array, how do I know how many things are in there? Yes, so that means, what do I want to plug in here? Does anybody have it all figured out?
Um,
So object.keys, students, and then what?
dot length minus one.
Dot length. Nope,
Oh.
not -1. So this is where the memorization comes into a problem.
Okay.
We know we do length -1 a lot to loop over stuff, but in this case, we actually care about how many things there are. So the total grades is however many keys there are in students, and every time we get a grade, we can say grade sum plus or equal to which means at the end, our average is what? Yes, and it seems REPL's backend is completely screwed right now, so you just have to trust me that this is going to work. But this is an example of, let's figure out how to traverse our data one at a time, figure out what we want, then figure out how to calculate what we actually want, how to store it, and then how to return it at the end. That is the same pattern in almost every problem we've done. But the tools that we've learned change based off of the data structure. But okay, that's all review. Are we cool with all that? Do we feel a little bit better with objects?
I do actually.
Good, I'm glad to hear that. I love objects. Okay, so we're moving on to the slides now. Today we cover object methods. What is an object method? Does anybody know? It is, yeah, but not all functions are object methods, right? So what is,
A function that runs a function?
nope, we're getting crazy. That's recursion. Yeah, okay, so real simply, a method is a function that is the value of a property on an object. So that was a lot of semantics. Basically, a method is a function that lives on an object. So on this object student, what is my method? What is a method? Say hi. It's the only property whose value is a function. And I really can't demo anything right now, but how would we call that function? So just like this, what does this do?
The
Yes. Okay, so what does just this do? What does this give me?
it will try to look for the key. Say hi.
Yeah, it's going to plug in say hi. It's just going to give me back this value, right? That's it. But if that value is a function and I want to invoke that function, what do I have to do? So when have we used methods before? They always kind of look like this. Two uppercases, one. Or everything on an array is a method. And console.log is probably the most familiar method as well. So this is annoying that I can't demo right now, but this say hi function, it's really stupid. It's saying, hi, I am Chris, but what's duplicated here?
The name, and you can just concatenate it.
Yes, yeah, that text Chris is duplicated. So if on the next line I said student.name is now equal to Gabe, and I did student.sayhi, what would it log out? Yeah, which means that it's basically broken, right? Every time the student changed its name, we'd have to update the code instead of say hi. So really, methods on objects need to do, I mean, they don't need to, but most of the time they need to use the data that's on themselves to be useful by any means. They usually want to use some of their own internal data. Did anybody have any clue how this one could be dynamic? Maybe from pre-reading.
Within the function, you can define a parameter with the name, and then
Okay, so I'm curious where you're going with this. What would this be?
put the parameter name within the function.
Okay, so then every time I call say hi, we're going to change this. What is this? Template literal. Does everyone see how this works?
Yeah.
So what's the clue that it's a template literal? What did I have to do to get that syntax? Backticks. Then I could do $ string interpolation. Yeah. So now, how would I make this work? I would have to pass into here.
I mean,
every time. I don't really want you to give my student what name he's going to say he is. I want the student to look at his or her own name and say what their name currently is. Any clue on how we could do that to make this really smart?
Why don't we just add the name itself from the object student?
Did you just do
Okay, so I did it there, but that's not fully dynamic.
Inside the function. Yeah, here.
What can I do here?
So plus student dot name.
Okay, so let's say I did that. What happens? Now what's going to happen? Not sure if we fully follow this yet because we haven't done pass by reference, pass by value. But what I did is I said, hey, I'm making a new variable other student. And other student should be whatever the current object of student is. So other student is now this. Student variable is now the number 10. And when I go to other student dot say hi, which will be this, say hi looks at the student variable to log out its name. And can I go to a number and say number dot name? No, I can't. Wow, they're broken today. After all that rant about CodePen, REPL, it's failing me. Yeah, so the problem here is you have the right idea. We want this to be dynamic. But we made this tied and expect that the code will have a variable called student. It's not only going to work on itself always. It's always going to point to whatever student is. If that variable changes, it's not going to work. So we're going to move to the slides in a second, but what we're looking for is this keyword here. This is one of the last keywords we're introducing in this course. It shows up in blue because it's a reserved keyword in JavaScript, the this keyword. And basically what it says is, hey, let me just make this clearer for a sec. This says, hey, whatever just called this function, that's the thing that I want to look at to access this property. And how we know what called the function is if we look at line 140, that's where the function got called. This is the thing to the left of the dot. So in the case that we call say hi on line 140, this will actually be whatever student is. And so it will be this specific object here. So that's the visual indicator when you say, hey, who is calling me? Well, it's whatever thing just did it over here. And that's kind of how arrays work under the hood. That every method only exists in one spot in JavaScript code, in code that creates a new array every time. And then we have 20 different variables that are all arrays, and they all go to the same method under the hood, really. But that method knows which one of them called it by whichever one just came before the dot push. And that's the array it uses as the this keyword. It's a little hard to demo right now, but do we kind of get how that works? That really that method only exists in one spot every time we create an array, but then each array is the value of this when we call it. And you know the current value of this is the one that called the method, and that's whatever came before the dot. Does that kind of make sense for where we're going? All right, we'll slow it down and go to the slides. What is a method in your own words? Yeah, and ideally it should use some of the data on that object to be helpful. Oh, this is a cool little app here if anybody uses Noisio. Like when I started developing to tune out the sounds of everybody around, there's this little extension you could get that you could like make ambient noise. And so I used that when I was taking tests here. But then once you're not fighting the code anymore, you could just listen to music and it's fine. But when I was a beginner, like any vocals in lyrics would like, you know, distract me. So that was a great app. I just wanted to give him a shout out. Yeah.
Sorry, to go back to the this.
Yeah, back to actual stuff. Yes, of course.
Because I was just thinking, because I guess I jumped ahead with something else, and this is using object constructor. So is that sort of like, because I'm just trying to make it make sense inside a method instead of an object. So whenever you're saying this, it's pretty much like you're just renaming that particular key value.
So I don't follow you on the semantics per se. So, okay, I don't want this to confuse the rest of the class, but we'll see because this is how it works under the hood. And I think part of your problem is like, hey, how do we know what this is if that object doesn't like exist yet? So pretend all right, so this might be a more useful example of how this works if CodePen is going to run. Because my student example was pretty flat. So it didn't make sense why we needed this until I showed you that we could change the variables. But what we have here is we have a function that every time we call it, it's going to return basically a brand new object. But all of those brand new objects will have a property called value, which will be whatever I passed into the function. And it will also have a function called sayThis that's going to log out itself. And so here, when I call getObject with x, it's going to create an object where it has a val property with the value x. And when we call sayThis, we'll be able to see that. Come on. Okay, when REPL fails, we'll use Chrome DevTools. Yeah, their server's fucked right now. Do you see this? Generally, the server responding with the status of 500 is not good. So this happened all at once. But if we can compare the two over here, basically this over here, these are the output from line 174 and 176. We have a function that every time we call it, it gives us back a brand new object. So x and y have nothing to do with each other than they came out of the same function, but that doesn't matter. It's like a template. That function uses a template to give us new objects where we expect each of those objects has those two properties. And so it shows here that while this sayThis function really only lives in this one spot, it's the only place the code is. If we call it on x, and we go to sayThis, well really, that x object is the property, is the value of the this keyword on that call. So we see here that when we called it for x, we do look at the object whose value is x. Yeah, can I zoom that in?
Could you? I left my glasses at home. Long time ago, my child.
Okay, so we're just looking at the output of these two lines over here and the code over here. Line 174 made this, and line 176 made this one. So we see in both cases, the this keyword points to the object that called it. When it was x.sayThis, we get back the object whose value is x. And when it was y.sayThis, we get back the object whose value was y. That's what makes this super useful, is that we can make one function to generate a bunch of objects, but each of them, when you call the methods on that object, it's going to know who themselves are. And the this keyword is what allows that. Visually on line 174, how did I know x is going to be the value of the this keyword? 174, how do we know what the value of this will be inside that method? Okay, so just on 174, when we call a function, how do we know what the value of the this keyword will be? When we call sayThis, the value of the this keyword and sayThis will be what? It's the thing that came to the left of the dot, which is x, and as you said, x is an object whose value is x. So, semantically, this isn't a great example, but it shows you how this works and how the this keyword works. That function's only in one spot, but if we call it from different objects, it's smart enough to know which object called it because of the this keyword. And we can double check that by just saying, hey, whichever array or element or object came before the dot, that's the value of the this keyword on this call. And so this allows me, with one small recipe for an object, I can make 100 objects that can all work with their own data sets. So we'll demo this tomorrow. We'll make a phone book. And then I'll say, how can we make multiple instances of this phone book? And you're going to say, we put it in a function and we spit out a new object. So we can make an American phone book and a European phone book. And all of them will use the same methods to add a number or delete a number or look up a number. And they'll use the this keyword. So when we go to AmericanPhoneBook.addNumber, which phone book will be the value of this keyword? Because it came before. That's basically all we need to know about this for the rest of this course. And this is one of the hardest things in JavaScript. So if we can follow that line of thinking, that's good enough for now. All right, back to the slides. We'll go over how to create, access, and run a method. And introduction to this, which you're already an expert at. How do we know what the value of this is? It's the thing before the dot. All right. Methods are actions you can perform on a value. We've used methods throughout this course, like index of, which is available on what data types? Not objects. It's on arrays and strings. Yeah. And because under the hood, both of those things are objects, and that's why JavaScript is wonky. And that's why the type of array is what?
Object.
Exactly. See, it's clicking now. So these methods are built into JavaScript. We don't have to define them ourselves. JavaScript does that when it sees we create when we create some data type with quotes around it or with brackets around it, it will make that really object under the hood act like an array or act like a string. So here we've got countries, and basically when we hit this line, when we hit this bracket, it's telling JavaScript, hey, go create an array for me under the hood and save it to the value of countries. It uses the array constructor function to do so, and this is just syntax for us. It's okay if you didn't get that. So country's index of Brazil is going to be what?
2.
Exactly. We can create our own methods too. So in this case, we're just making an object called Grace Hopper, and she's got 3 properties, which are all strings. But we know that we could store any value on a property of an object. So in this case, we made a property called myMethod, and its value is a function that when we log it out, it says, hey, I'm from a method. So on line 11, we call it like this. We select the object, which is just Grace Hopper. Then we say, hey, we want to go a level deeper. So we've got the dot. And then we specify the property name that we want to do, and it's hard-coded. We're saying we're looking for a property with the exact value, myMethod. We could do this with bracket notation too. It's worth knowing that this could easily be this. Again, we're just selecting a value or a property on an object, and if we know it's a function, we can invoke it. And so what I said to the left of the dot, in this example here, what is really to the left of the dot? Grace Hopper, right? We're not confused on that. The dot doesn't specifically impact this. It's more so, what is the thing that went a level deeper to access the function? Does that make sense? Cool. So this method is really useless. It could totally exist somewhere else and just be called a normal function because it doesn't have anything really to do with Grace Hopper. So generally, a method should perform an action that's relevant to the concept of the object, which in this case, I guess loosely, we could say, hey, this is Grace Hopper saying a quote. I guess this quote is relevant to Grace Hopper, but it doesn't really use any data on the object, but that's okay. We select it in the same way, we run it, we get this on the screen, nothing new, right? And over here, this, I think, is Alana's first suggestion or somebody's suggestion. Hey, if we wanted to make this function useful, why don't we pass data into it? And so in this case, they're hard coding in, basically, this must be the year that she was born. They've hard coded in 1906. And every time we call get age, we're responsible for passing in what the current year is, which again is pretty useless because we can make this dynamic and automatically happen. But you get the idea. We can access a method and we can plug a piece of data into it just like any other function, right? But this might be a little bit easier if instead we stored on Grace Hopper what her birth year was. And this function just took the current year and subtracted her birth year. And the user wasn't responsible for hard coding 1906 or passing in the current year. Does that kind of make sense? So let's try to make it more useful again. Let's make a greet function that this time takes the name, and we'll have Grace Hopper greet that person. But what is duplicated in here? Yeah, rank and last name. So if somehow Grace Hopper is canonized and becomes a saint, and her rank is no longer Rear Admiral but is now a saint, and I change that on the next line, I say gracehopper.rank equals saint, this function will be outdated. We don't want that value hard-coded on the property and in the function. We want it to always look at itself and say, hey, I should use my current rank and my current last name. But for now, this is how we would do it. But it's stupid. So, better idea, we can make it dynamic by referencing the variable of this object, right? Someone else in this class suggested this approach also. This will work, but how could we break it?
If we remove the rank.
Okay, so maybe, but no. It's more so that right now this is dependent on the variable being Grace Hopper, right? If we just name this something else, then it's looking at the wrong object. Or if in our demo, I made a new object called gracehopper2 equals to Grace Hopper, and then changed the original Grace Hopper to be a number, well, when we try to go to number.rank, it's going to completely break the whole program. So this is currently dynamic, but it's really too tied into the variable name existing as that variable name. So what is the only way that we can make it totally dynamic? This keyword. See, you know where we're going with this. JavaScript has a keyword, this. It shows up in blue. It's a reserved keyword. And you can use it to refer to the object that is currently calling the method. So in this case, on line 13, what object is currently calling the method? Because, exactly, but if it was brackets, does it matter?
No, it doesn't.
Makes no difference. What's the calling object here? Grace Hopper. It's the thing that accessed the method. So greet is a method on Grace Hopper. This is the calling object.
What if it's like 2 levels in? It's just still the left.
So that is a good question. But so like, I don't know if you can follow this without the visual, but pretend that greet was an object. And greet had a property, ASDSD or whatever, that is a method. What's the calling object there?
Greet.
Yes, it's this one. The thing that directly holds the method below it will be the value of the this keyword. So that's a great question. Okay, and then just one more demo. No difference here either, right? Has nothing to do with how we actually access the method, whether it was dot notation, whether it was brackets, or whether it was brackets with a dynamic variable. I just want you to get used to seeing those are all different ways to just select a property on an object. Once you've selected it, it matters what thing holds the method. And it's still Grace Hopper. But you should be comfortable with all 3 of the ways I just demoed how to access a property.
But why would anybody use it that way?
This way?
Yeah.
Okay, so one example would be, and I think we have a visual of this later in the slides, pretend that we had a calculator, right? There's a calculator object. And I have different methods called sum and divide and multiply or whatever. My main function that says process user input is going to look at the key that you just typed, whether it was a divide or a plus or a minus. And those map to strings of sum or calculator, whatever. And those strings map to the actual function I want to run. So that's how I could dynamically run a method. But we'll get the visual in a couple slides, I believe. And now in this case, we made a function called getThis. For whatever reason, it just returns literally a reference to the same exact object, which allows us to say returned object equals gracehopper.getThis. So if we go to returned object out first, what will that value be? Yeah, it's literally the same exact object. We just have two different variables referring to it, which means this is true. And again, we actually cover all of this tomorrow. Here we go. So a calculator is actually a really good way that sort of this object-oriented style where we could make a whole object that represents the real-life functionality of a calculator could exist like this. We'll have two properties called num1 and num2. And when you type in a number, I'll update one of those. And then when you type in any of the four mathematical operators, I can call one of these functions, clear out the second number, and update the first number.
Yeah, my question was, why would you use the square bracket notation instead of just using the dot notation?
In the example of Grace Hopper, if we generally knew exactly what method we were going to, so yes, we'd use dot notation. But on the internal code in here, I only want one function where I'm going to calculate all of your inputs. Oh, this is so ugly in here. So pretend user input is actually mapped to sum or difference. And I don't know which one it's going to be because you're going to hit the plus or minus sign. So then I dynamically go to the method that you just hit a key for, and I can call it with the two numbers inside. So this is a case where we would dynamically grab a method. The Grace Hopper example, no, we knew what we're looking for, but if I made this calculator in the right way, I wouldn't have 20 different cases for every key you just hit. I want one main function that'll process your input, and there I can dynamically go perform one of those methods. Does this make sense? We haven't fully built out the calculator, but this is where it's headed. Might not be. So in this case, Rebels back up. Good. Now this isn't actually code in here. It's user input is going to be sum or difference, right? Those are two strings that map to these functions. So I can dynamically plug that string in to go to the correct function to add or subtract your numbers. Does that kind of make sense? So dynamic keys are definitely a thing we use a lot with objects, and sometimes we use them to map to object methods. This isn't fully built out, so it's hard to show the example, but this is an example of where that would happen. Okay, you'll figure it out when we get to an example where you have to do that. So in this case, if we called the sum function, or let me just delete this so we can see it. If we called sum function at line 12, the sum is 50 because num1 is 20 and num2 is 30. So when we go to calc.sum, it says, hey, go look at the object that called, which is calculator, whose number 1 is 20 and whose number 2 is 30. We get back 50. Then on this line on 13, we change num2 to be 15. So when we go here, we say num1 on this, which is calc, which is still this. 20 minus 15 now is 5. Does that make sense? So there is a lot more to the this keyword. And JavaScript is an object-oriented language, which means almost everything inside the language is built as objects, which is why you've seen wonky stuff with the type of array. And that's why strings can be accessed by a key. That index, that I, is actually a key because the string is actually an object under the hood. And all of those methods on those data types need to know which thing just called them. And that's where the this keyword comes into play. So we've only skimmed the surface of the this keyword, but it's all you need to know to start writing objects that do more work and that are a lot more useful. And we just have to know how is the value of this going to be calculated, which I think you get by this point. So what is a method?
Some function that lives in
Yeah.
object or data.
And we could have many different versions of an object that all came from sort of the same recipe, like I demoed earlier. How will those methods know which object is calling them? Yeah, what's the keyword they use to know which object? Yeah, and we can double check what that keyword is by looking at the thing that accessed the method, the thing that came before the dot or the bracket with a dynamic variable. That's how we can make our objects a lot more useful, but this really shouldn't, does this keyword seem that complicated today? It's kind of a little bit more straightforward, right, compared to other topics. So really, the skills that we're still practicing is how do we deal with nested data structures and select one thing at a time and know how to get the piece of data that we want. That's the overarching skill that we need to practice and get comfortable with before we can really solve problems, which is organizing data in the correct way and then accessing the bits of data that you need. That's the main thing to continually work on and not be confused by the dot notation or the bracket, and knowing when we need to interpolate the value of a variable as its string value to get a key, or when we're safe to do dot notation. That's the main thing that I would still focus on. But the this keyword, you should be well equipped to start using it and make smarter objects. And tomorrow we will go a little deep into how the computer actually works to pass around objects and arrays, the complex data types versus the primitives. Remember last week I whipped out the whiteboard and we got a glimpse of it? That's what tomorrow's lecture is on. So after tomorrow, you've kind of been introduced to all of the data types in JavaScript, how we use them, what the benefits of them are. And from there is when we move into the third portion of the class, which is functional programming. And it's going to rely on us having a really good grasp of everything up until this point. What? No.
What are we gonna do?
Tomorrow's pass by reference, pass by value, which sort of sums up everything with the complex data types. Then we move into higher order functions, which is the example I did earlier with the array.every. Every was a function that took in a function.
And that's Wednesday, Thursday we're doing that?
Yes.
Okay.
Yep.
2 more days to like master everything else.
Yes. But that's where like we start to really understand this lower level stuff. Functional programming makes your code a lot more readable and could collapse your Sudoku algorithms into less than 10 lines. So functional programming is awesome. But to really reap the benefits, we have to understand all this lower level stuff. But that's where I think it gets more fun and maybe overwhelming at the same time at first. Cool?
Not overwhelming.
All right, do we have any questions? All right, 5-minute break and then workshop.